This service technician is about to take an oil sample. The customer's machine is equipped with a factory-installed oil sampling valve, so he doesn't have to use a vacuum hand pump. He seems to know what he's doing and has probably done oil sampling many times in the past. Obtaining a sample bottle of oil is neither difficult nor time-consuming, but it plays a vital role in protecting the performance and value that's built into every Caterpillar machine. An oil sample may spot serious problems such as dirt entry, contamination by fuel or coolant, or even that a bearing is beginning to fail due to fatigue. Consistent sampling permits the oil sampler to analyze trends. In order to be a useful and effective management tool, SOS analysis results must be timely and accurate. At first glance, it looked like the technician performed the sampling procedure correctly. However, upon closer observation, he has already made 5 careless mistakes that have most likely damaged the reliability of the sampling. Were you able to detect all 5 errors? We'll identify them later. Again, oil sampling is easy to do, but it's just as easy to make mistakes and do it the wrong way. This video will show you the proper method of taking reliable oil samples so that you can detect problems before they lead to costly repairs and downtime. We'll look at the oil sampling procedure on machines with and without factory-installed sampling valves. We'll also advise you of the importance of complete information about each sample in order to maintain proper consistency and information accuracy. Let's begin with the 4 factors that affect the contents of an oil sample. The first factor is lubricating oil. The oil used will obviously influence any sample. Poor quality, improper viscosity, and wrong API rating all affect analysis results. The second factor is outside contamination. The presence of dirt, fuel, water, or antifreeze signals trouble in any oil sample. The third factor is wear. This is caused by daily operating procedures, which produce an expected amount of normal wear particles. However, oil sampling can indicate premature or accelerated wear due to improperly installed or adjusted components. And the fourth factor is the condition of the used oil sample. The degree of oxidation or sulfation and the amount of soot in the sample are very important. Keep in mind that the length of oil change intervals and the amount of makeup or added oil between changes affect the condition of oil in the sample. Obviously, oil analysis is extremely important because it detects internal problems before they lead to failure. Therefore, it's equally important that an oil sample reflects the true fluid condition of a system's internal operation and not have its reliability damaged by accidental contamination during the sampling procedure. To avoid external contamination during oil sampling, never take oil from the drain stream, a waste oil container, a used filter, or filter housing. Most of the time, we cannot see particles that may have entered the oil taken during the sampling procedure. For example, airborne dirt, a strand of hair, or fine debris from a dirty shop rag can affect the particle count during oil examination and result in an inaccurate analysis. In this demonstration, look at how just 1/2 of a crushed aspirin tablet greatly affected an International Standard Organization, ISO, count during lab testing. Most new Caterpillar machines have oil sampling valves for each pressurized oil system, including engine, transmission, and hydraulic. Sampling by valve is more reliable because the sample comes from a consistent known location where the oil is well mixed and circulated and represents oil condition accurately. Caterpillar recommends that machine owners upgrade their older machines by having them retrofitted with oil sampling valves. It is easy and inexpensive to add them. In addition to being more reliable, sampling valves make oil sampling faster and more convenient than using a vacuum pump. However, the suction gun method of oil sampling is still used widely, so we'll demonstrate the proper procedure for both methods. Keep in mind that no matter what method you use to take an oil sample, you must exercise machine implement and steering oils to agitate the contaminants and to heat hydraulic oil to operating temperature. Therefore, before you take any oil sample, either by using a live oil sampling valve probe or vacuum pump, Always warm up the machine first. After fluids in the system have been utilized, machine implements exercised, and the oil is at operating temperature, you're ready to take an oil sample. Let's look at taking an oil sample from a machine that's equipped with a factory-installed valve. This preferred sampling method requires using a probe and approximately 6 inches or 15 centimeters of tubing. Always use a new piece of tubing for each oil sample. It's especially important to discard the tubing after taking the oil sample because oil additives and contaminants may remain in the tubing and contaminate other samples. Also, dirty supplies will contaminate your samples and cause inaccurate test results. Keep new sample bottles capped and store them in dust-free plastic bags. And be sure your valves, probes, tubing, and vacuum pump are protected from dust during storage. There are 4 basic steps in the live oil sampling valve procedure. Step 1. Make sure the machine is at operating temperature. Set the engine at low idle and remove the dust cap from the valve of the compartment you are sampling. Clean the sampling valve with a lint-free clean cloth, such as a 162-5791 cat shop towel. Step 2. Insert the probe into the valve and collect about 4 fluid ounces, or about 100 milliliters of oil, into an appropriate waste container. This flushing process cleans the valve and helps ensure a representative sample. Make sure you properly dispose of the waste oil. If the oil flow is slow at low idle, it might be necessary to raise the engine RPM while extracting the sample. Note, make sure the machine is not in a standby high-pressure circuit. Step 3. Before you actually take the sample, it's important to clean the sample bottle with oil from the system. Insert the probe into the valve and fill the sample bottle only halfway. Cap the bottle and shake it vigorously to remove any possible contaminants inside it. Be sure to discard the oil into an appropriate waste container. Now you're ready to take the sample. Reinsert the probe into the valve and fill the bottle 3/4 full. Do not fill to the top. Also, do not allow any dirt to enter the bottle or bottle cap. Step 4. Withdraw the probe from the valve and secure the bottle cap. Then place the bottle with the properly completed label into the shipping cylinder and send the sample as soon as possible to your lab for oil analysis. Later, we'll show you the proper way to identify the bottle by using the standard CAT sample label so that you ensure accurate SOS results. Now, let's look at how to take a good oil sample using a method for systems that are not equipped with sampling valves. This sampling method requires a vacuum pump. Always use a new piece of tubing after sampling any oil because oil additives or contaminants may remain in the tubing. There are 5 basic steps in the vacuum extraction method of sampling. Step 1. Turn the engine off. Measure and cut new tubing to the length of the dipstick. If the compartment you are sampling does not have a dipstick, cut the tubing so that it reaches about halfway into the oil depth. Step 2. Insert the tubing through the head of the vacuum pump and tighten the retaining nut. The tubing should extend about 1 inch or 4 centimeters beyond the base of the vacuum pump head. Step 3. Install a new clean sampling bottle onto the vacuum pump and insert the end of the tubing into the oil. Do not allow the tubing to touch the bottom of the compartment. Step 4. Pump the handle to create a vacuum. Hold the pump upright because if you turn it over, oil may contaminate the pump. If oil enters the pump, disassemble and clean it. Note, before you actually take the sample, it's important to clean the sample bottle with oil from the system. Insert the end of the tubing into the oil and fill the sample bottle only halfway. Cap the bottle and shake it vigorously to remove any possible contaminants inside it. Be sure to discard the oil into an appropriate waste container. Now you're ready to take the sample. Again, insert the end of the tubing into the oil. Then fill the bottle 3/4 full. Do not fill to the top. Step 5. Withdraw the tubing from the compartment. Then remove the bottle from the vacuum pump and secure the cap on the bottle. Place the bottle with the properly completed label into the shipping cylinder. Properly discard the used tubing and never reuse it. Now that we've seen how to correctly take an oil sample using a valve probe and how to take a sample using a vacuum pump, let's return to the service technician at the beginning of this video and identify some common errors. An oil sampling video replay of the technician will reveal his 5 mistakes. Right from the start, the technician makes mistake number 1. He takes a new sample bottle from his shirt pocket and then sets it down on the machine. He should have brought the sample bottle in a sealed, dust-free plastic bag and kept it stored that way until he was ready to use it. Therefore, there's a high probability the machine's sample oil has already been exposed to external contamination. Here's mistake number 2. He did not flush the sampling valve before taking a sample. As a result, he's sampling from a possibly dirty valve that has a tendency to trap debris. Now watch closely for mistake number 3. Notice that he fills the sample bottle to the top instead of the required 3/4 full. This error leads to mistakes number 4 and number 5. When he overfilled the sample bottle, some oil spilled down the side. He made mistake number 4 by not immediately putting the cap onto the bottle to secure the oil sample. Instead, he reaches into his back pocket for a rag in order to wipe the bottle clean. If failure to immediately secure the bottle cap didn't contaminate this oil sample, then using a dirty shop rag surely did. The technician made mistake number 5 by allowing outside particles to enter the bottle and damage the sample's reliability. How many mistakes did you identify? And more importantly, how many of these common errors have you made when performing oil sampling? Remember, oil sampling is easy to do, but even easier to do wrong. We stopped counting the technician's errors at 5, but there could have been more. For example, did the label he filled out include all the necessary information? Too often, missing information makes it nearly impossible for an interpreter to provide correct recommendations for customers. Because completing label information in the field is difficult, especially when you have to keep track of sampling supplies and your hands are soiled, we suggest you prepare a label for each sample to be taken before you go to the field. Once you're out in the field, you can add needed information when taking each sample. Obviously, the model and serial number are imperative, but can be written on each label while in the office. You can obtain oil type and viscosity and the meter reading of your last oil change from shop records. Service meter units on both equipment and oil are very important. It's also critical to indicate whether or not you changed the oil when you took the sample. Also, it's extremely important to indicate the amount of makeup or added oil since the last sample. If a significant quantity of oil was added, it can dramatically change the interpretation of sample results. New oil samples are necessary for oil condition analysis. When you receive a new brand or shipment of bulk oil, submit a sample and indicate the classification of the oil on the label. This new oil information is stored in the laboratory instrument as a reference during the analysis of each used oil sample. After you correctly complete all of the required information on the label, send the sample to the lab immediately because test results that forecast failure are no good if they get back to you too late. If you're not currently using an SOS program, please recommend this valuable service. If an SOS program is already in place, keep in mind that your results are only as good as your commitment to regular sampling at each recommended interval. Trending of the oil analysis results greatly enhances the interpreter's ability to make accurate recommendations. For additional information, please see the list of helpful references and their form numbers at the end of this video. Turn the simple process of oil sampling, sophisticated analysis, and clear, easy-to-understand reporting into a mutual commitment to protect the performance and value built into every Caterpillar machine. Use the full potential of the SOS program to reduce costs and maintain productivity by performing oil sampling the right way.